All right, test takers, welcome back to Exam Prep Solutions. In this video, we're going to be doing a dynamics problem. It's a collision between two balls. We're going to find one of the ball's velocities post-collision, and there's a little bit of a twist in this problem, so this will be a really interesting one. If you want to learn how to solve any FE exam problem in 5 steps, download our free guide below in the description. It's 100% free, and yeah, let's jump right into the problem. Okay, so here's the question we have. Based on the figure seen below, find the velocity of ball 2 after impact if the collision was perfectly elastic. Ball 1 had an initial velocity of 5 meters per second and a post-collision velocity of 3 meters per second. Ball 2 had an initial velocity of 8 meters per second. So these are showing the balls before collision here and then what they're doing after collision. I'm just going to label their velocities underneath here. So we want the velocity of ball 2 after collision. So that's what we're trying to find in this problem. Ball 1 had initial velocity of 5 meters per second here. Ball 2 had initial velocity of 8, and then ball 1 had a post-collision velocity of 3. And then we also know that the collision was perfectly elastic, and that's going to come into play here. So given we were given V1 post, which is usually indicated by V prime, V2, and then what we're actually trying to find here is the velocity of ball 2 after the collision. And we're also given something E equals 1, and I will explain what that means here. So let's go over to the FE manual and let's look up collisions. And let's see what we can find here in the dynamics section. So I searched elastic, and when the collision is perfectly elastic and energy is conserved, E equals 1. So that's why I have E equals 1 written over here in this section. So that's going to come important when we go to the next part of the equation here, which is if we see here, we want to find the velocity of the ball 2 after the collision. And there's an equation given right here. So it's V prime of 2. So that's our next step. We're going to identify what equation we're going to use. V prime of 2 equals, and I'm just going to move this back over here so we can see it. V prime of 2 equals M1, so mass of the first ball here, and then we have V1, 1 plus E. We know E is 1 for that. I'll fill in the rest of the values. Then we're going to have E times M1 minus M2 times V2's initial velocity. That's all going to be over the mass of both balls. So we have M1 plus M2 here. So let's fill in all the values given again. So you get V prime of 2. So mass of ball 1, well, it was 2 kilograms. There. What was V1? Well, V1 had a velocity of 5. Times 2 because 1 plus 1 minus 1 times N1, well, it had a velocity, a mass of 2 kilograms, minus M2, which was 3, all times V2, which was 8, over the mass of both balls over 5. And if we calculate all that out, V prime of 2 is going to equal 8 meters per second. Normal to the plane here. So it went back this way at 8 meters per second, despite also having the initial velocity of 8 meters per second. So if we go to, so we know that the velocity of ball 2 after the collision was 8 meters per second. If we go to our choices over here in the problem, we can then select answer A, which was 8 meters per second here for the problem. So that is how to find the velocity of the ball after a collision that is perfectly elastic. Download that free guide to learn the 5 steps to solving the FE problem, and I'll see you guys in the next video.